Hello, let us solve a very simple problem using a system state test calc, which is used for evaluating properties and states of a closed system. The background for this can be found in chapters 0, 1, and 3 in the textbook. So let's start with a particular problem. So we have a block of iron going from state 1 to state 2, and several properties for state 1 and 2 are given in this problem. We have to find the change in stored energy and the contribution to that change because of the change in velocity or the change in temperature, etc. So let's begin by launching the appropriate test calc. I'm already logged in. So we go to the TESTCalc tab, and there we click on system states because the problem involves a system, a block of iron in this case, and iron being a solid, we pick the solid liquid model. Notice that if I put the pointer over a model anywhere, a description appears. And that takes us to the test calc page, which has 4 different tabs. We're currently on the examples tab, and this, by clicking the show hide button, this particular video will show up here. And then to launch the test calc, we go there. You can see that there is an animation tab and discussion tab where you can learn more about the SL model. And in the discussion tab, obviously, you can put your comment or participate in any discussion involving this particular test calc. So as you can see, the test calc takes a little while to load, but once it loads, it's very fast. It runs, because it's a Java applet, it runs in your local system at very high speed without any need for internet access. So simply put, the state test calc is composed of the state panel and the IO panel. In the state panel, what we got is that this is the state number. You can choose a state number, and then it's basically a collection of properties. Each property symbol, you can see there is there's a state number appended after the symbol. As you move the pointer over a particular symbol, its definition, I mean what it means, kind of appears at the bottom right here. Also, in the IO panel, you can do calculations, simple engineering calculations, and we'll get back to that later. So first thing first you select the material, which is in this case a block of iron. So let's go down, find iron here. Oops. There we go. So for iron, we start entering properties. For state 1, what we know are temperature is given, which is 30 degrees Celsius, and the velocity and height are already initialized to 0 values, and the mass is given as 50 kilogram. We just click the calculate button or the enter key to produce the variables that can be calculated from the given input. Notice that the stored energy, the specific stored energy, has been calculated. That's what we are after. We want to know the change in it as the state changes. So you go now to state 2, and you can select a state by clicking on this choice or just going up or down with the arrows. A calculated state, you will notice, has a symbol C in front of it. So state 1, you can see, has been already calculated. We can go back there by selecting it. So let's go back to state 2 and start calculating it. The temperature given is 300 degrees Celsius. We enter that. Velocity is 50 meter per second. Again, it could be in any given unit. We could just select the unit here, and the test calc will automatically convert it to SI units to solve the problem. Uh, the elevation in this case is 50 meter, and of course the mass hasn't changed. So again we know the specific stored energy. So to find the change in the stored energy, total energy, we can write this, evaluate this expression, m1 times E2 minus E1. So the answer is 6162 kilojoules as the change in stored energy. So how do we know what is the contribution, for instance, because the velocity changed? So to do so, we go to state 3 and we'll say, you know what, temperature didn't change. Temperature is 3, same as T1. Only velocity changed to the value of velocity 2, VEL2. And height also didn't change, so height remains the same as Z1. And of course mass didn't change, which is equals m1. So this state 3, has only change in it is the velocity. So therefore now if we evaluate the change in stored energy, we can evaluate that as what? As E3 minus E1 instead of let me correct that, E1, and we get only 62.5. So notice that the change in velocity produces only 1% of the change in energy that is seen in this problem. So bulk of the change in energy happens because of the change in temperature. Likewise, you can show that if the change in height also contributes very little bit to the net change of energy in this case. One of the features I just want to mention about, again, as we solve more problems, we'll bring out more and more features of these test calcs. If you click the super calculate button, for instance, suppose it recalculates everything with the given information. You can change something. For instance, you say it's not iron, it's copper. So if you select copper here, and now you click the super calculate button, all the states are recalculated with copper as the material. Not just that, in the I/O panel you'll find a detailed output of all your calculations are produced. State 1, all kinds of properties with copper as your material. State 2 and 3 have been recalculated. A table has been calculated here, which you can copy and paste on an Excel sheet. And finally, a bunch of statements, which is like called the test code, is produced here. The beauty of this code is that you can just copy this and you can copy and paste it. Suppose I copy it and let's say I initialize the entire test calc. That means we just launched the test calc another time, and you can paste the test code here on the I/O panel and click the load button. What happens is that all the states that we calculated before are again recalculated. In other words, if you have a solution to a problem and you save the test codes, you can come back and paste it back on the same test calc and click this load button to reproduce the solution. That's a pretty convenient feature of test calcs. Well, let me stop here and discuss some other features in another future video.